Hi, Madam. Today we will present about the course registration and timetable system. We come from Group 5.
My name is Teo DJ, and my student ID is 242DT 242JS.
And my name is Pan Kang Hong. My student ID is 242DT 242HX.
My name is Ho Ming Hui. My student ID is 242DT 242JM.
My name is Clement Lee Heng. My student ID is 242DT 24221G.
Okay, so for our agenda is introduction and problem statement and stakeholder and requirement education, elicitation, and is the system requirement and system constraint and CBA, and diagram overview, data transformation and contract integration pattern and summary and Q&A. So for the next part is introduction. I will pass to Theory G, my team member, to present.
Now I will talk about the introduction. The system purpose is automatic course registration and timetable management for higher learning institution. Key feature is real-time course search and enrollment, and dynamic timetable update and integration with department system. Key problem solved is inconsistent data format across department, resolved using editor pattern and observer pattern. And next, we will talk about the stakeholder and elicitation methods. And elicitation methods use interview and server, document analysis, observation, and brainstorming section. And the primary stakeholder have student, primary user, administration, system management, and academic department, and the timetable management provider. Now, the second is identified stakeholder. The primary direct user is student, core user who registration and register and view timetable. And the administration manage the system, cost, and user. Then the lecturer is access schedule and student roster. Secondary indirect impact is academic department provide course data via APIs. And the timetable management is external scheduling provider. And the third one is technical support for system management and integration. The last one is university management for decision make and policy setter. And the next one is the elicitation methods applied. We use 5 structure approach. The first one is the interview, one-on-one section with administration and student reps. And the second one is a server or questionnaires to describe to 50 more potential student user. And the third one is the document analysis to review course categories and existing manual API document. And the fourth is process over station watch current manual registration workflow. And the last one is the brainstorming section. It for teams ideation to identify hidden requirements. And the next one is the key feeders from elicitation. From the student, 92% wanted real-time conflicts detection and 85% prefer mobile notification for change. The last is filtration with current manual timetable checking. And for the administration part is time-consuming manual data entry between systems. And the second is differently taking registration compliance. And the last is need for centralized reporting dashboard. For the technical stuff is currency system integration change and data format inconsistence across department. And the last is security and scalability concerns. This one is impact on system design. This is based on the stakeholder feedback we provided, the real-time conflict detection, and the centralized dashboard for the admin request. And the third one is the updated pattern for the legacy integration for the IT request. And another is multiple notification channel for for student preferences. And the last one is the automated pre-request checking for the academic policy need. Now I will pass for my next member.
Okay, so now I will present about the requirement elicitation. So for the brief introduction for requirement elicitation is to ensure that the proposed course legislation and timetable system address the need of all stakeholders. Structured requirement elicitation process will conduct the process involve identify the main user group and applying multiple elicitation techniques to gather functional, operational, and technical requirement based on the collected input. A set of finalized system requirement was derived, followed by targeted sample question used to validate and refine test requirement. So for the sample question for student and the admin, for the student, and the first is the identify main setback during course decision, and the second is understand how student manage the schedule conflict, and the third is the determine require course information before the registration. So and the explore expectation for full course and waitlist handling. So and the last is the identify preferred timetable format and usability need. So for the admin part, the first is the identify percentage of manual or overridden registration, and the second is understand common registration error each semester, and the third is the determine useful analytic for course planning, and the last is the understand approval process for special case. So next is the sample question for the faculty and the IT staff. So for the faculty member, for the first is identify student information needed as semester start, and the second is understand need for schedule or room change update. And the third is the identify tools required for teaching schedule management, and the last is the review current method for prerequisite monitoring. So for the IT staff, for the first is the identify integration requirement with existing system, and the second is determine security and data privacy requirement, and the third is the estimate peer system and user role, and the last is the define backup recovery and data retention policies. So next, I will talk about the system requirement overview. So for the key requirement for student is the advanced course search. So filter course by semester, course, faculty, instructor, time, credit, and mod course planning and shopping cart. And add, remove, and save course plan using a shopping chat system config detection. And the third is the automatically detect schedule classes and suggest alternative prerequisites checking for the and the verify prerequisite is the core requirement, credit limit and program rules registration submission is the one-click online registration with confirmation, PDF receipts, and email personal schedule manager. So now is the key requirement for the system admin. So for the first is the academic catalog management. This can manage course, semester, schedules, integral, and capacity, student academic profile control, and view and update student record status and ability. So for the registration overrider, this can approve special cases such as full classes or missing the prerequisites. So for the policy and system configuration, this can configure registration periods, academic rules, and user roles. And the analytic and reporting, this can monitor enrollment trend, wait list, and classroom users. And the last is the key requirement for the staff. So for the first teaching schedule view, for this can view assign course, classroom enrollment, and config student roster management. And this can access student list attendance, grouping, and explore option course communication tools. So for the scan, send announcement message, and manage discussion forum, academic monitoring, track reverses, student process, and academic alert. So now I will pass to my good member Park Kang Kong to present.
Okay, so now I will present about the system constraints. So for the first one, the system constraints is time constraints. So for the time constraint, system must be ready before trimester 1, 2026 registration. So the maintenance only during low usage period. There's the break and the weekends. So for the project duration is the 30 week. So for the week 1 until week 8 is design and documentation. Week 9 until week 11 is to prototype and testing. And the week 30 is to the final submission. So for the next one is about the scope constraint. So they have three scope constraints. The first one is include in current scope. So the basic course registration and timetable management. And the second one is basic administrator reporting. And the third one is web-based standard user interface. And the last one is simulator external system integration. So for the second one is the excluded from current scope. So there is the mobile application development. The second one is the advanced analytic and prediction features. And the third one is real financial or identity system integration. The last one is multi-language and real-time collaboration tools. Last one is the feature limitation. So maximum concurrent user is 1000, that's already test. And the historical data retention, current plus last 2 academic year, and the non-critical data sign every 15 minutes. For the backup is weekly, full, and daily incremental. So for the next one is about the cost and resources constraint. So they have the two, the first about the budget limitation. So we have using the ringgit ratio 0 to develop the budget because this is the academic project and this free type cloud and university resource only. And we're using the open sources and free software only, and no budget for training or external service. So for the resources availability, we have 4 student developer with various skill levels. The next one is 10 to 15 hours or week per member. We are the undergraduate level technical skill, and we have standard personal computer use and limitation instructor consultation. And the next part is about the technical and operational constraint. So at the front, at the front end, we have using the HTML, CSS, and JavaScript. And then backend, we have using the Java, Python, and PHP. So for the database part, we have using the MySQL, PostgreSQL, and most concurrent user, we already have 1,000. So for the supporter browser, we have using the Chrome and the Firefox. This is the latest version, and the basic security and role-based access control. So for the cost benefit analysis, CBA, a 10% discount factor is applied over a 3-year evolution period. The purpose is assess long-term feasibility and return on investment. That's called the ROI. So the estimate cost for the development, we have using the 16,000, and the hardware we have used the 6,000. Software we have using the 4,500. User training we have using the 2,000, and the maintenance we have using the 5,000. For the data backup and security, we only use the 2,000. So the cost cover system development, operation, and ongoing maintenance. The benefit include improved registration efficiency and reduce administrative workload. For the next is the estimate benefit is the per year. So the staff time saving is 25,000. There's the reduced manual registration and timetable adjustment. For the improved registration accuracy, we have using the 20,000. There's the automatic validation, reduce error. For the reduced administrative cost, there is using the 8,000, less paperwork and manual scheduling. The improved user certification, the improved user certification, we have using the 18,000. There's better registration experience and feedback. The data analytic value have using the 5,000 insight for academic planning. So the total estimate annual benefit is 76,000. For the next one is the CBI calculation. So you can see at the right side have a table. So after calculation, the MPV, we get the 94,800. So for the ROI calculation, we have get the 100.38%. So the payback period calculation, the payback period is 15.26 months. So for the next part, I will pass to my team member, Ho Ming Hui, to talk about the use case diagram.
Okay, so this diagram shows the use case of the course decision and timetable system. So the system involves 3 main users: student, lecturer, and the admin. So students are the main user of the system. They can search and register for the course, view the timetable, and the system will automatically check for prerequisite, requirement, and schedule conflict. This helps students avoid registration error. So for the lecturer part, lecturer use the system to manage their teaching schedule, view enrollment, student, and submit grade. They can also approve special requests such as course overrided. So for the admin part, admin manage the overall system. They control course information, registration period, timetable, and general report to monitor enrollment and system performance. Overall, this system improve efficacy, reduce manual work, and ensure that academic rules are properly encoded. That's all for this diagram. So now I will pass to my next team member, Kramer Japan, to present the class diagram.
So now I will present the class diagram. So the core entities for this diagram is student course registration and timetable. Purpose on this diagram is visually represent the key entities within the academic course registration system, their defining attributes, and the structural relationship between them. It serves as a critical blueprint for both the system object-oriented design and the subsequent relational database schema. So for the key component is entity and attributes. Each entity like student course is defined with its core properties, student ID, course name, and the second is relationship. The association between entities such as student and register for a course are debated, often including cardinality. And the last one is system behavior. Essential operation like add cost and confirm registration are included to illustrate the system dynamic functionality. So the primary outcome for this diagram is establish the foundational data model, ensuring clarity in entity interaction and providing a direct guide for efficient and normalized database design. So I will pass to Pang Kang Hong to present.
Okay, so now I will present about the activity diagram. So at this part, we have the 2 diagram is the student registration flow that will show the step-by-step process from login to confirmation. And the second one is the lecturer workflow. There is illustrator, course management, and grading process. So in the first, I will present about the student registration flow. So the first we can see is the student login. When they are login, can browse the course list and select the course and system will check the schedule conflict. So when system check the schedule conflict, if have conflict, it will show the conflict message. Then back to the select course session. If not conflict, it will go to the check prerequisite. So it will, in the next part, it will check the prerequisite met. So if prerequisite met is no, it will show the warning and back to the select course session. So if yes, it will confirm the registration and save the registration, and then it will generate the timetable. So after generate the timetable, it will display the confirmation. Then that's the all of the student registration flow. So for the next part, I will present about the lecturer workflow. So for the lecturer workflow, in the first, lecturer will log in, and after lecturer log in, it will see the assigned course. Then the lecturer can select the course. So after lecturer select the course, the system will check the schedule conflict. So if conflict, if yes, it will show the conflict message, and then it will return to the select course session. If no conflict, it will check the registration status. After system check the registration status, the system will ask, need to adjust course info. So if yes, lecturer can edit the course time or capacity, then save change and view enroll student. If no, the lecturer can just view enroll student. So after view the enroll student, the system will ask the lecturer want to add or remove the student. So if yes, the lecturer can modify the student list and save change. If no, just end the process for the lecturer workflow. So that's all of the lecturer workflow. And the next part, I will pass to my team member, Doriji, to present about the data transformation.
Now I will present about the data transformation. They have the three parts. The first is the mapping. It is matching file name between the system. And the second is the contract. And this is the rule that data must follow. And the last one is the decoupling to keeping system separated but connected. And the next one is the data mapping. This is the student portal for the central database. And the next one is the student name. It will become the student underscore name. And the third one is the course code, and it will become the course underscore code. And the fourth is the Monday at AM. It will become the month 08 and 00. And the last one is the research. All systems speak the same language. And the next one is the data contract. And the rule every data must follow. Like student ID will have the S plus the 7 number, like S1234567. And the course code must be exit in the course list. The semester will become like 2026 spring format. And the status is only in the registered or drop or wait list. And the data contract benefits is stop bad data from entering system. And the decoupling is the all way all system connected directly to message. Our way is the service layer in middle, like student portal to the service and that go to the database, or can at the service go to the timetable and the notification. The decoupling benefit is change one system without the breaking other. And the benefit have the less error, no manual tapping mistake, and faster install update vs waiting day. And the third one is a reliable, same rule for everyone. And the fourth one is the easy to update to change one part only. And the result better for student, easier for admin. I'll pass to my team member, Clement Lee.
So now I will present about the integration patterns. This section presents the integration design pattern used in the system. So including adapter pattern for reaching incompatible interface with external service, facets pattern for simplifying complex subsystem interaction, mediator pattern for managing communication between subsystem, observer pattern for enabling real-time notification. So this pattern ensures the system is modular, maintainable, and scalable while integrating seamlessly with existing university service and providing a smooth user experience. So the first one is adapter pattern. The purpose is the bridge incompatible interface use case connect the internal system to external service like the university notification service, and the benefit is allows integration without modifying the internal system code. The diagram is course registration system, submit registration, sign timetable, use timetable adapter, convert format, send to scheduler, calls to external schedule API, receive schedule. This adapter convert internal data format into those expected by the external scheduler, enabling seamless communication. And the second is facet pattern. The purpose is simplify complex subsystem interaction. Use case is provide a single unified interface for the student portal to access registration, timetable, and notification service. The benefit is reduce complexity for end user and client system. The diagram shows student portal register cost, withdraw cost, interacts to registration facet, validate registration, allocate timetable, send notification, and registration facet coordinate with the three subsystem is registration DB store record, timetable scheduler, allocate, assign slots, and notification service, notify, send message. The facets handle all underlying operation, making the student portal interaction simple and consistent. Third one is mediator pattern optional. The purpose is manage and coordinate communication between multiple subsystems. Use case is coordinate timetable scheduler, faculty management, and classroom allocation. Benefit reduce direct dependencies between modules, promoting loss coupling. The diagram show mediator, coordinate allocation, check conflicts, communicate with faculty system, provide lecturer availability and preference. Classroom allocated, reserve room for physical space. Timetable scheduler, request slot for time allocation. The mediator ensure all components work together without directly referencing each other, simplifying update and maintenance. Last one is observer pattern, also optional. Purpose is enables real-time event-driven notification. Use case notifies student and service or registration or timetable change. Benefit is improved user experience with timely automatic updates. The diagram show registration DB subject, update status, trigger notification, observer student portal, receive update and notification service, receive update. And when the registration status change, all subscript observer are automatically notified without the subject needing to know their details. So for the summary is system integrate course registration, timetable management and notification, use facet and adapter pattern to handle complexity and compatibility, design for scalability, maintainability, and future expansion, provide clear benefit, time saving, accuracy, user satisfaction, and analytics value. So for the last part is the Q&A part, reflection and contribution. So for me, I learned how integration design patterns are applied to manage communication between different system components and improve overall system structure. My contribution to this project include designing the class diagram and applying the adapter, facet, mediator, and observer patterns. I spent several weeks working on my assigned tasks, including understanding the patterns, designing the diagrams, and preparing the presentation. One of the main challenges was distinguishing between the different design patterns and selecting the most appropriate one for each integration scenario.
Okay, so for my opinion, I learned to analysis, system construct, balance, project factor, and model workflow with activity diagram while handling data integration. So for the summary of my contribution to the project is I define system constraint, create activity diagram, and design data mapping process for smooth integration. So for the time spent completing my assigned part is about 20 hours to 7 on analysis, 8 on diagram, 5 on data mapping. So for the challenge faced during this project, I think is the aligning constraint with scope, ensuring correct data mapping, and keeping diagram consistent. That's all my opinion.
Okay, so I have learned how to gather and analysis system requirement compatible by identifying stakeholder need and creating the use case diagram. Spend around 10 to 12 hours on my task and face challenging, understanding all user requirement and keeping the diagram clear and simple for presentation. That's all for me.
So I learned the fixing Miguel's conflict in give and matching scheduler with teammate. That is for our presentation. Thank you.
Thank you.
Thank you.
Thank you.